This is Kilo 1, November, Bravo Tango. A couple of months ago, I presented an introduction to emergency communication. In that presentation, I focused on the use of 2-meter FM simplex as the basic fallback communication mode in the worst-case scenario of infrastructure and communication system failure. In every area of the world, there are regional emergencies, hurricanes, tornadoes, earthquakes, fires, tsunamis, and so on. But in each of these situations, there are surrounding areas that have working communication systems. But what if the grid goes down in more than just our local area? Would we be able to communicate with one another and be able to pass traffic for the EMA and other clients? In my introduction a couple of months ago, I talked about the effects of a coronal mass ejection and an electromagnetic pulse. In those scenarios, it is likely our computers, phones, and many of our radios will be damaged. But at the same time, there will be a very critical need for communication. FM simplex is a reliable, proven line-of-sight mode and is the primary mode and skill set for an emergency team member. The second mode that has been proven, tested, and still being used by the military, FEMA, U.S. Forest Service, Mars, and RACES, and others is HF, Near Vertical Incident Skywave, or NVIS. NVIS is a technique that will cover York County and surrounding areas. With this method, the received signals are coming almost straight down, and the transmitted signals are going almost straight up. Hills, ridges, valleys, and other tall obstructions don't block the signal. Using the NVIS technique will provide coverage from 0 to about 400 miles out. Much of the focus of amateur radio literature is long-distance communication, or known as DX, which results in a long skip zone. If you are an HF, you've experienced the stations that you can't hear, but someone 400 miles from you can hear very clearly. It's because your skip zone and the other station's skip zone is overlapping. Or you can hear someone in Ohio but not the ham 20 miles away. So briefly, I want to talk about NVIS. Near Vertical Incident Skywave is a radio propagation method for reliable communication over a radius of 0 to 400 miles. There's no need for infrastructure, repeaters, or satellites. NVIS uses antennas with a very high radiation angle. NVIS never uses vertical antennas, and antennas for NVIS must be low, 20 feet or less above ground. High antennas and vertical antennas create a ground wave in addition to a sky wave. In the near field, the ground wave and the refracted sky wave reaches the receiver at different times, creating a distorted and unreadable signal. NVIS covers the area normally within the skip zone, but there is no skip zone unless you create it. Think of squirting water through a hose straight up. You cover the area close around you. The United States Marine Corps tests have proven NVIS highly reliable. In the Marine Corps test, 20 watts proved 100% reliable in a 200-mile radius. NVIS is a technique based on antenna radiation angle and height, use of an appropriate frequency, and power level. Here's the desired radiation pattern for the NVIS technique. Antenna height above ground dramatically affects the radiation pattern and the amount of ground wave. As you can see, the radiation pattern of your antenna changes depending on the height above ground. At a full wavelength high, a dipole has distinct lobes and almost no vertical radiation and creates a substantial ground wave. It's a great DX antenna, but not for NVIS. At 3/4 and half wave height, there's still a powerful ground wave. At about a quarter wavelength high, the pattern begins to consolidate into a globe shape, and the lower you go, the more vertical it becomes. Now, most of us have NVIS antennas, whether we know it or not, because few of us have a way to get our antennas up high enough. A quarter wave length for 80 meters would be 60 feet, more or less. A good 40 to 80 meter compromise for NVIS would be 20 feet or lower. Of course, we've all heard or read the scoffing remarks about cloud warmer antennas, but that is exactly what is needed for NVIS. The lower antenna attenuates the ground wave, which could cause interference. Good NVIS antennas are horizontal dipoles, inverted V with a gentle 120 degrees or flatter slope, a horizontal end-fed or horizontal loops, just no verticals. Most of us don't have the real estate to support 160 meter antennas, so 40, 60, and 75, 80 meter antennas will do the job. Now let's talk about frequencies. The frequencies that will refract at a vertical angle are 40 meter days, 80 meter nights, and sometimes 60 meters or 160 meters. As long as we have the internet, we can use a MUF map. There are several live MUF maps online that refresh every 15 minutes. What we are looking for is the maximum usable frequency, or MUF. The propagation condition changes throughout the 24-hour period due to the effect of the sun on the ionosphere. Also notice on the map that the green color in our area ranges from 3.5 to 4.5, so we'll use 4 as a round number. Now once we know the MUF, we can calculate the FOT, that is the frequency of optimum traffic, FOT, which is about 85% of MUF. The lowest usable frequency, the LUF, is 25% of MUF. So we have from 25% of MUF all the way up to MUF. Here's an example based on the MUF map shown here. MUF on the map is 4 megahertz. 85% of 4 is 3.4 megahertz. 25% of the 4 is 1 megahertz. So we can see that all of the 75 80 meter and the 160 meter band are usable. Using NVIS, it is likely that the transmitting and receiving station are experiencing the same frequency of optimum traffic. If there's no internet, then a frequency plan would need to be agreed upon for a way to find one another on the dial. Here's an example that is used by a Mars group in another state. They begin their net on these frequencies, then shift up and down the dial as the conditions change. A prepared frequency plan and training will help us find one another in an emergency. Now let's talk about power level. NVIS does not require high power. Low power portable stations do well on NVIS. Stations transmitted at 20 to 25 watts have high reliability. There is no need for infrastructure, repeaters, or satellites. So in summary, with a combination of HF NVIS and 2 meter simplex, a very reliable communication network could be established that would cover our whole county and the surrounding areas. Now this was a very basic introduction to the concept of NVIS. Obviously, I didn't cover every nuance of NVIS. I would recommend a good book on the subject. It's long out of print, but if you do a Google search, you'll find a PDF version on the net for free. The name of the book is Near Vertical Incident Skywave Communication, and it's by David Fiedler and Edward Farmer, and it was printed in 1996. Thank you for the opportunity to share this information. This is Kilo 1, November, Bravo Tango.